Hi! I'm trying out a new, I'm testing out a new, totally new video trying, and I think I might have just restarted this recording. I'm not sure. Right now we're doing circuit training using tables in pre-calculus. I wanted to show you how to do this whole thing fairly quickly because you really need to do a review. You need to understand how to do everything to begin with. So that's why I'm making us do this one together completely. So we got -9/2 for number 1. We found the answer of -9/2 over here. We have an answer of 0. Oops, by the way, this should be number 2. So we're looking for is 0 as an answer, and I believe that's on the second page. Well, by golly, it is. Look at that. It is right here. Okay? All right, so now we want to look at f of 2 plus g of 3 plus h of 0. I don't think this part is too hard, so I'm going to go through it fairly quickly. So f of 2 is 0. G of 3 is pi over 4. H of 0 is 4. That would be nice if that was the way the answer looked, but it's not. You could even rewrite this as pi over 4 plus 4. It's still not an answer that you will find. And you can look and check. You always want to look and check, especially if it's multiple choice. But this one, actually, you really don't find that answer. I can look at the whole thing and I don't see it. So that means I need to manipulate the answer. Usually, if there's a fraction involved, it means getting a common denominator and adding them together. Common denominator being 4. So this could be pi over 4 plus, if we take the denominator times 4, we get 16 over 4. And that will give us pi plus 16 over 4. And then we go find that, and it was on the previous page, the first page. Oops, I forgot to put the number on this. This is number 3, which means the next one is number 4. And that's going to be down here at the very bottom. Here we go. Number 4. All right, so we're looking for f of 4. Let me bring in my table here so we can see it a little better. Put it right there. All right, so we want f of 4. That means we're going to go down to 4 over to f, and that is 6 over h of 0, here's 0, over to h is 4. We want to simplify that fraction to 3 over 2. Okay, so 3 over 2, and you will find that up here right under the table on the front page. That is number 5 then. This is where it starts to get a little harder. So 3 times g of 1. I'm just going to write in what is g of 1. 1. G of 1 is square root of 2. So that's 3 square root of 2. Okay? And then it says plus sine of g, 2 sine of g of 3. Now honestly, we're just going to go with just the inside of the insidest of parentheses, so the smallest piece. So I'm going to put 2 sine, and I'll figure out what g of 3 is. So 3 times... Oh, I don't have an eraser on this one. Dog goodness. Okay, so g of 3 is pi over 4. I hope that makes sense. I forgot to bring my erasable pens home. Ooh, missed those things. Then we have cosine of h of 4. So that's cosine, and I'll just find h of 4. 4 and h. Negative pi over 2. All right, now this is where people have some issues. I mean, I know you know this is 3 square root of 2, but do you know the sign of pi over 4? And you may have forgotten all that stuff. You're going to have to bring back your unit circle. You've got to have the unit circle in your head. If you don't have it in your head, then I want you to print it out, get an image. You can use Miss Latham's that you had last year, and if you're a couple of my AB calculus people, you can bring in I gave you a unit circle also, or you can go on the internet and you can find a image of the unit circle, because you must memorize it. So we're going to kind of talk about it as we go along. I'm going to take and have a little bit of extra space right here, and that won't be in our box, but I do want to talk about it. So I know you know what 3 square root of 2 is. I'm not concerned about that. I am concerned that you know what sine of pi over 4 is. And if you don't, that means you need to work on your unit circle. And I'm going to give you plenty of opportunity for that. But for right now, let's just make a unit circle. It's a lovely circle, isn't it? Okay, we're going to take a look at this unit circle, and what we want to do is locate where pi over 4 would be. I'm hoping you kind of remember it's going to be between 0 and pi over 2. And you notice I'm not using degrees. We always use radian measurement in calculus. Okay, so pi over 4 is somewhere around here. And what we're wanting for a unit circle is an xy coordinate. That xy coordinate is going to be your cosine and your sine. Remember, cosine is your x coordinate on the unit circle, and your sine is the y coordinate on your unit circle. And you know what truth is, my friends? You simply have to know what that pi over 4 measurement is. I'm going to have to put that to the side here. It's one of those, you got to memorize it. Okay, I don't want you to go through making a right triangle and figuring out that pi over 4 is 45 degrees and trying to figure all that out. You just need to know it. So if you don't already have memorized that unit circle or you've forgotten it, I'm going to have to give you some opportunities to memorize it a little better. And we may have to do that. We'll see. Anyway, so we're looking for, back up to here, the sine of pi over 4. That's the y value. And I'm hoping you remember that is, let me put that in a different color so you can see it better, square root of 2 over 2. Funny thing is, cosine is the same thing at pi over 4. But anyway, the sine of pi over 4 is square root of 2 over 2. So when I come back here, I've got 3 square root of 2 plus 2, and it's times, and we can put in that square root of 2 over 2 from our sine. Now, let's go to cosine. Cosine's a little different. I'm going to make a new unit circle so we can look at it, because it says negative pi over 2. So we are going backwards. How strange is that? Make another unit circle here. I'm sorry, I'm taking care of my daughter's dogs. If I don't kill them, they'll be fine. But anyway, negative pi over 2. Again, remember that each quadrant we go from 0 to pi over 2 to pi, pi to 3 pi over 2, and then back to 2 pi. You remember that? I hope you do. Just ignore that mangy dog below me. Shh, dog. There is nothing here. Okay, anyway, negative pi over 2 means instead of going counterclockwise, going around the circle this way like we did with pi over 4, we're going the backwards route. Okay? It's going backwards, and we're going backwards because it's a negative, and we're going pi over 2, which would put us right here. Now it's asking for cosine of negative pi over 2, which means I'm looking for the x value. Now you should know unit circle means that you are the radius of the circle is 1, and that coordinate would be 0 for the x, negative 1 for the y. Remember, cosine is the x, sine is your y. So cosine of negative pi over 2 is simply going to be, not negative 1, 0. 0. Okay? It's just going to be 0 because that's the cosine of negative pi over 2, the x value. All right. Now that's great. Wouldn't that be nice if we were done? We're not. So we need to clean it up because there's no answer that looks exactly like this. You should see that you can, for 2 times square root of 2 over 2, you can cancel out your 2's, and you're left with 3 square root of 2 plus square root of 2. So that's square root of 2 plus 1 square root of 2, which gives you 4 square roots of 2. And if you look around on your answers, I think I'm going to have to go to the second page. Okay. Am I on? Do I have this right? Yeah. Oh, wait. No. I'm sorry. I apologize, guys. I've got so many papers here. So 4 square root of 2 is right here. It's on the second page, first column, almost at the bottom. Not quite, though. Right here. All right. We'll bring in our table, and let's see if we can figure this out. Let's see. What was that number that we just did, by the way? Y'all are probably yelling at me, telling me that was number 5, so this is number 6. All right. So P of x is equal to h of x minus g of x, and they want you to find P of 1. So let's first find out what is P of, well, we can go ahead and do this. We can replace the x value with 1, which means P of 1 equals h of 1 minus g of 1. Anyway, okay, so we go to the x value of 1, which is 2, and then g of 1 is square root of 2. I don't think there's a whole lot I can do with that. We just got to go find it. 2 minus square root of 2. Whew. All right, let's see. I don't see it on this. Whoop, yes, I do see it on this side. It is on this side. It's at the top right corner. So this would be number 7. Woohoo! Number 7. Dog's starting to freak me out. My husband's out of town and it's dark, you know. Anyway. All right, so, all right, let's see if we can do this particular problem. This particular problem, you've got w of x equals e to the h of x. All right, and plus 5 times f of x squared, and they want you to find, oops, sorry, can't see it, w of 3. So I'm going to go ahead and plug in the 3 where I see an x. Means we've got w of 3 equals h of 3 plus 5 times f of 3. And now we just look at our table and figure this out. This is no big deal. We can do this. So h of 3, blonk, down to 3, over, boom, is 0. So e to the 0 plus 5 times f of 3. Gee, many crickets, dog. You're freaking me out. Negative 1 squared. Okay. So, now remember anything, I don't care what it is, to the 0 power will be 1. So e to the 0 is 1. Negative 1 squared is 1 times 5 is 5. So we end up with a 6. And I'm going to go looking for 6. Oh, I didn't have to look very far, did I? Right there. Boy, I hope I'm right on that one. Number 8. R of x, and they give you R of x, and they want you to find R of 0. So again, we're going to do the same thing. Plug in a 0 everywhere we see an x. Not a big deal today. And then you simply find what, oops, bring this in. Simply find, if you look at 0, go over to f, it's negative 2. So square root of 7 minus 2. Did I just get that right? Minus a negative 2. That makes a big difference. Minus a negative is a positive. So square root of 9 is 3. Ooh, I hope we've got that answer somewhere. Let's look and see. Yep, we do. So that's number 8. Other page, second column. You should see a 3. We'll put a number 9 there. It says, for what values of x does h of x equal g of x? Oh, a little more complex here. So I got to look at my table. Let's see, let me put it in a place you can see real good. Where does h of x equal g of x? That's pretty easy. Let's just go. These are the two columns with h of x and g of x. Where are they matching? They are matching. Where x is equal to 5. Boy, that wasn't that bad. So where x equal 5. And again, we look for the value, and we find 5 on the other page. It's on the first column. This will be number 10. Now this is where we need to take a second because a lot of people have problems with inverses. This does say inverse function of h of x. Let it be defined as the inverse of h of x. Well, that's pretty obvious. Find the inverse function of h of 2. So inverses, if you remember, inverses mean we are taking x and we are taking y and we are flipping it. So as an example up here, and I think I did this on the last video, but just in case, h of x, if h of x has a point 3, 4, the inverse function of x is going to be 4, 3. 3, 4. Flip it. Okay? So when you look at the inverse function of h of 2, instead of looking down the x column, I'm looking down the h of x column and I find the 2 and I look at the x and I get a 1. Boom. That's it. So your answer is 1. Let's look for the 1 as the answer. Well, looky there. It's right down at the bottom right on the same page. 11. There you go. For what x value is p of x equal to g of x plus 5 over f of x minus 6 undefined? Now for this function to be undefined, in this case you've got a numerator and a denominator. So you want to take the denominator and you want to set it to 0. Okay, so let's do that. Because if the denominator is 0, then that means that the whole thing is undefined. All of p of x is undefined. Okay, so what I want to do is take f of x minus 6, and I'm going to set it to 0 and solve. That means where is f of x equal to 6? Bring our table in. I'm looking at f of x. Where is it equal to 6? Well, it's where x is equal to 4. So x equal 4. All right, so again, I'm looking for the answer number 4. I think it must be on the other page. It is. It's on the other page, second column. So this will be number 12. This question is g of 3 over g of 4. That's simple because all we're doing is using our table. G of 3 is pi over 4. G of 4 is negative 4/3. Oh man. Okay. All right, so looking at this, you've got fractions within fractions, and sometimes that freaks people out. Please don't let it freak you out. I really don't want it to. Now, you can formally write this. Remember, this is any kind of a fraction is division, really. So it's like pi over 4 divided by negative 4 over 3. So you could think of it this way. This is one way to do it. This is the slow way of doing it. And we know that when you divide fractions, you change that to multiplication and you make it pi over 4 times the reciprocal negative 3 over 4. So we know that much, and you can do that. But I want to show you the quick and easy, all right? Because really, I think it's easier to skip this step if you understand you've got division, pi over 4 divided by. All you want to do is multiply and flip the bottom fraction down here. So you can go directly to this second step without having to do this step. So just keep that in mind. We'll do that and talk about it as we go. Okay. Oh, my goodness gracious. So I end up getting, when you multiply this, there's no canceling, unfortunately, so negative 3 pi over 16. Oops, I went to red somehow. All right, and ooh, there it is over here, number 13. Oops, you don't see that, do you? Number 13. Ooh, a composite function. Let's see if we can even say it. G of the inverse of h of 0. Lord, there's a lot of ofs in that. So don't freak out over it. Like any big project or anything big, you just want to take it one step at a time. Go with the inside of your parentheses first. So the inside would be inverse function of h of 0. And we remember from when we talked about inverses a minute ago, when we're looking for the inverse, we really look, if we're looking for the inverse of a function, instead of looking at the x values, we are going to look at the h of x value. So let's find where h of x is 0 right there. And then we'll come over and see the x value is 3. So that means that h, and maybe I'll put that right here. Let me put that in a different color to make it a little more understandable. Inverse function of 0 is equal to 3. So g, that means we have g of 3. So g of 3, come down to 3, and we look over at g, and we get pi over 4. Wait a minute, that's too easy for you guys. All right, so let's find where positive pi over 4 is, and I see it on the other page. All right, so we will make this number 14. This one, oh gosh, I hope I left myself enough room. I kind of messed myself up there. All right, so we're going to find g of 3 because this is p of x. So we're going to make that p of 3, changing the x to the 3. So we'll just change all the x's to 3's. G of 3 plus 5 and f of 3 minus 6. So g of 3, again, we are really just using the table. So go to 3, go to g, pi over 4. This is just going to be some basic math, really. Over f of 3, negative 1, minus 6. Make sure I got that right. Doesn't sound right, but okay. All right. All right, so we're going to see what we get here. Now, in this top piece right here, pi over 4 plus 5, I'm probably going to need to get a common denominator. So this is 5 over 1. I'm going to change that 1 to a 4. It means I multiply. So pi over 4 plus 20 over 4. I don't need to do much down here. That's just going to be negative 7, right? Equals pi over 4 plus 20 over 4 is going to give me pi plus 20 over 4, and that's all over negative 7. Okay? Now, this is a fraction, pi plus 20 over 4 divided by negative 7. And guys, remember what I said before. Just go ahead and write this, and truthfully, it's just the denominator times the denominator if you can figure that out or remember it. But if you need to see it, how that comes about, it's pi plus 20 over 4 times, remember you get the reciprocal of 7 over 1 or negative 7 over 1, and you would get negative 1 over 7, which is pi plus 20 over 28. I hope that matches something. Oh, I forgot the negative. And you can put the negative up top, but if you put it up top, you're going to have to make the pi and the 20 negative because it would be the entire numerator would be negatized. But you can put it in the denominator too, and you notice that when you go over on the same page, but on the second column, there's your answer. 14, that's 15. This one says find the average rate of change of h of x on a closed interval from 0 to 4. So average rate of change, remember, is just, and I like to write the abbreviation AROC, average rate of change. That's just a slope of a secant line that connects the 2 points where x is 0 and y, or x is 0 and x is 4, so 2 points. All you got to do is find the equation of the slope. Remember, that's just delta y over delta x, or the change in y over the change in x. Okay, in other words, I'm going to go a little slow. I won't always do this. So in other words, h of 4 minus h of 0 over 4 minus 0. There's your formula. And I've just simply looked for the answer. So I'm going to look for the h of 4, which is negative pi over 2. They can't make anything easy, can they? Minus h of 0, which is 4. Oh, goodness. All over 4. Looks like I'm going to have to do a little bit of manipulation. So, common denominator here, of course, is 2. So that's a negative pi over 2 minus 8 over 2 all over 4. All I did was change the 4 to 8 over 2. Combine those fractions, giving you a negative pi minus 8 over 2 over 4. Oh, that's not looking too easily good. All right. So we're going to take that 2 denominator times denominator, 2 times 4. That makes this negative pi minus 8 over 8. Is anything like that looking like what we have? And you can look on both pages and you won't find it exactly like that, which could mean I made a mistake. It could also mean that we need to, we need to work a little harder on this. And what I mean by harder, we can do a few things to this. Remember, once I get here, I can manipulate. Since this is negative pi minus 8 over 8, I could write that as negative pi over 8 minus 8 over 8. Oh, I seem to have run out of room. So negative pi over 8, there's not a whole lot I can do, but 8 over 8 can be 1. And then, if you look over right here, there's your answer. Just catty corner down, go to 16. All right, let's talk about arc sine. This does kind of throw people off. I think I did this one in the last video, but just in case. Arc sine is another way of saying inverse sine. I'm going to write it as inverse sine. Some people remember that easier. Plus arc secant. That's just ugliness. Okay. Some people remember that better. All right, I'm going to use a little extra paper here because I think you're going to need it for this. Put those up there so you can see what I'm doing. All right. So when you're dealing with an inverse, I need you to realize, for example, that if you have sine of theta equals some x value, that's the same thing as saying the inverse sine of x is equal to theta. You're just flipping the angle with the x value. Oh, goodness. Heavens, it froze. Wonder if I press pause, what would happen? What I've noticed is that I lose everything when I press pause. I want to try this. If not, then hopefully you can figure out the rest. Hold on. Wow. I think that this new recording platform works a lot better, okay, because I had to do some fixing to make this work, and you didn't have to see it. That's good. All right, so that, the inverse sine, you have to remember what that is. Now, so since this says the inverse sine, I'm just going to say inverse sine right here. Let me do that in color. Do it in green. So inverse sine of f of 3. Now, guys, let's go ahead and find f of 3 here. Use our table. We'll come down to 3. F of 3 is negative 1. What is inverse sine of negative 1? What that tells me is that if I have a unit circle, which I should have if I don't memorize it, sitting right in front of me. The question is where, remember, sine represents the y value on the unit circle itself. So where is -1 on your unit circle? And I'm hoping you see this point right here at the bottom is 0, x value of 0, y value of -1. That means the inverse sine is whatever this angle is. And hopefully you remember that. That's 1 pi, pi, 3 pi over 2. So 3 pi over 2. There's several ways to say that angle, but we're just doing it this way for right now. So 3 pi over 2 is what I kind of get there. So inverse sine of f of 3, 3 pi over 2. Now inverse secant is a little bit more difficult. Fold that down. Okay, the old school way of doing this. Inverse secant. All right, so I want you to remember that secant of x is actually, let's do this in a color so it stands out. Let's make it red instead of that. Secant of x equals 1 over cosine of x. That's one of the reciprocal functions I do want you to start to think about. Okay, I do need you to remember that. So, and remember when you've got the inverse function, that's just flipping things around. So let's go ahead and figure out what is g of 1, because what we're looking for then is we are looking for the inverse function of g of 1. So 1 square root of 2. Okay, and remember the inverse function of secant of some, of some x value is equal to an angle of some sort. Right? Okay. And that means that secant of theta equals x. Right? All right, well, if secant of theta equals x, then 1 over cosine of some angle is equal to x, right? So what this tells me is the x value is the theta value, square root of 2 over 2. Okay, that, or not the theta value, the x value is square root of 2 over 2. Okay. Oh, geez, Papa, you're scaring me to death. So that tells me that, oops, you can't see what I'm doing. I'm so sorry. So 1 over square root of 2, because that's stupid. Sorry. Got distracted by that dog. X equals square root of 2. So I can say that square root of 2 is equal to 1 over cosine of theta. Now that's still not telling me anything. Because in order for me to find the inverse value of cosine, I've got to find out what theta is. I have to find out what theta is. All right, well, I'm going to have to see a little bit more maybe. Some of you may already know the answer. If you do, move on. Because really, if you know your unit circle really well, you would probably know what that angle measurement is. But if you don't, it's going to take a minute more. So I'm going to solve for cosine. I'm going to multiply by cosine. I'm going to divide by cosine. I don't know what, phooey. It's getting late at night. I'm going to blame it on that anyway. All right. So cosine of theta is equal to 1 over square root of 2. Now, I think you can rationalize here. I believe you remember how to do that. Rationalize means getting rid of that radical in the denominator. And I do that because, number 1, we're supposed to, but number 2, when we do this, it becomes familiar. Where is cosine of theta equal to square root of 2 over 2? Well, I'm hoping you remember that one because we just did it. It ends up giving you an angle measurement of pi over 4. So theta is pi over 4. What that means is the inverse secant of square root of 2 is pi over 4. All right, so this over here is plus pi over 4. This is the humdinger, by the way. In fact, it's pretty tough. All right, when you combine these together, we need to have a common denominator. So I'm going to change the 2 to a 4, multiply by 2. 6 pi plus pi over 4 gives me 7 pi over 4. Now, when I look all over the place, I unfortunately do not find this 7 pi over 4 anywhere. Gee, that's frustrating. But I want you to remember your unit circle. Get sick of hearing that, aren't you? First off, let's find where 7 pi over 4 would be. 7 pi over 4. Remember, this whole circle, the whole rotation is 2 pi, which is another way of saying 8 pi over 4. So we are just 1 pi less than coming, or 1 pi over 4 less. So this would give me 7 pi over 4. But remember coterminal angles. You can call an angle measurement by a couple of different names. Counterclockwise would be 7 pi over 4. If we go clockwise, okay, that way, that would be like 2 pi. Remember, this is pi over 4, or 7 pi over 4. That'd be like 7 pi over 4, but we have to go another pi over 4 to get to 2 pi. So it would, if I go backwards, it's like 2 pi minus 7 pi over 4, which is another way of saying negative pi over 4, which guess what? We're doing good because that gives us the last answer, and that's what we wanted. Lord, I hope you got something out of this. You guys let me know if you need some help.